We are tracking the life of an entity with no pulse. It doesn't breathe, it doesn't sleep, and it cannot die. Its life began in the cold pre-dawn desert of New Mexico in 1945, when the sky violently ignited. This was the Trinity test. At exactly 15 seconds after detonation, the blast radius had already expanded a full 100 meters across the desert floor. The theoretical conception happened over a decade earlier. In the 1930s, physicists like Leo Szilard realized that the atom, previously thought to be a solid, indivisible block of matter, held an enormous, terrifying reservoir of hidden energy. To release that energy, you force an element like uranium-235 into supercriticality. You shoot a single uncharged neutron into a heavy nucleus. The atom splits, releasing immense energy and kicking out new neutrons, which then split other atoms in a runaway exponential chain reaction. The successful delivery at Alamogordo proved the math was right. A whiteboard equation regarding subatomic physics had materialized into a functional weapon, moving the project from the laboratory to the battlefield. 3 weeks later, the weapon made its public debut over Japan. The atomic bombings of Hiroshima and Nagasaki instantly flattened entire cityscapes, creating blast pressures and heat so intense they vaporized human beings, leaving a death toll approaching 200,000. The physical shockwave was only the immediate cause of death. The weapon left behind a lingering toxic footprint, severe acute radiation sickness, decades of elevated cancer rates from radioactive fallout, and the looming environmental threat of a soot-choked atmosphere known as nuclear winter. Yet military strategists argued this same terrifying capacity for mass death had an undeniable utility. The sheer shock of the bombings forced a rapid Japanese surrender, abruptly ending the deadliest conventional war in human history. This created a bizarre standoff between global superpowers. If two nations both hold weapons capable of wiping out millions of civilians in an afternoon, initiating a war guarantees your own destruction. The psychology of global conflict inverted. Safety was no longer guaranteed by defensive walls or superior troop numbers, but by the mutual promise of total annihilation. In the 1950s, the weapon matured into the Teller-Ulam design. A fission explosion acts as a primary trigger, compressing and heating a secondary hydrogen capsule until it fuses. This birthed the hydrogen bomb, jumping yields from kilotons to megatons, hundreds of times more powerful than Hiroshima. These high-yield atmospheric tests produced multi-layered condensation rings, reaching past the tropopause into the stratosphere, capable of carrying radioactive debris across entirely different continents. To maximize this new power, the weapon was integrated with emerging aerospace technology. Intercontinental ballistic missiles allowed a megaton payload to be launched in a high arc across the globe, over the horizon, and directly into enemy territory. By mounting these ballistic missiles onto submarines, the weapon could hide silently in the deep ocean, immune to a preemptive strike. This completed the nuclear triad: land, air, and sea capabilities. Technological integration turned the bomb into an omnipresent force. With the triad complete, any coordinate on Earth sat within a pressurized 30-minute strike window. Tracking the spread of nuclear weapons, the Soviet Union's 1949 test triggered a global arms race. The UK, France, China, India, Pakistan, North Korea, and Israel developed arsenals. As technology spread, militaries bred localized variants, developing non-strategic, tactical nuclear weapons designed strictly for battlefield use. These included atomic demolition munitions meant to blow up bridges or dams, naval depth charges to destroy submarines, and direct-fire nuclear artillery shells. Distributing smaller, highly volatile nuclear weapons to ground troops and localized commanders drastically increased the statistical probability of a fatal miscalculation. The Cold War era was littered with broken arrows, military shorthand for accidents involving a nuclear weapon. Bombers carrying active hydrogen bombs collided in midair, caught fire on runways, and accidentally dropped multi-megaton payloads into the ocean and across farmland. As radioactive fallout from testing poisoned the atmosphere and near-miss accidents piled up, an intense global backlash formed. Millions of citizens marched to demand strict governance over an entity that threatened human extinction. In response, international coalitions built diplomatic straitjackets. Agreements like the Non-Proliferation Treaty and the Comprehensive Nuclear Test Ban Treaty sought to cap the spread of the technology and outright ban explosive testing. This stark line graph charts the quantitative success of those disarmament campaigns. From a terrifying peak of over 64,000 active warheads in 1986, the global stockpile has steadily plunged to roughly 9,600 today. But looking back at the sheer volume of accidents, false radar alarms, and geopolitical crises, military historians and commanders often point to a deeply unsettling conclusion. Humanity escaped the Cold War primarily through plain, dumb luck. Today, the surviving weapons are aging, but the major nuclear states are pouring trillions of dollars into modernizing their delivery systems, even as historic restraint treaties begin to fray. The Bulletin of the Atomic Scientists tracks this ongoing threat via the Doomsday Clock. Driven by rogue state proliferation and escalating superpower conflicts, the clock currently sits at just 89 seconds to midnight, the closest to global catastrophe it has ever been. We can dismantle the warheads and defuse the missiles, but we cannot uninvent the physics of fission and fusion. The DNA of the bomb is a permanent fixture of human knowledge. In 1945, we engineered the one tool capable of uncreating us. We are locked into a perpetual, inescapable parentage with the bomb, where our only option is to manage it perfectly, forever.